Hi, this is Mr. Max. So what I have here, I have a few equations that I have worked out that I want you to try and solve with me. Right, so the first one here, you have 9 raised to the power x is equal to 54. Now, when you write 9 and 54 in prime factor form, you can't make the bases the same. So the best to do here is to solve this by taking the logarithms of both sides. So log 9 to the power x is equal to log 54. And then what you do is then you apply the power law of logs by bringing that indice or that power, that index right in front of the log 9. And from here, you divide throughout by log 9 in order to isolate the x. Now, this is a typical 3-mark question in the examination, all right? And then you give your answer to 3 significant figures if that is the required degree of accuracy. My second one here is also similar, but then what you have on the right is you have a decimal 0.008, and on this side you have what 5 raised to the power of 2x minus 1. So you're going to change that decimal to a fraction, number one, and I'm just going to simplify that fraction, so it gives me 1 over 125. All right, and I'm going to write 125 because I can recognize it that it's a power of 5. Actually, 5 raised to the power of 3 gives you 125. Right, and then when you rewrite it in 5 raised to the power negative a third, it's the same as 1 over 5 raised to the power of 3. Now, what you realize here is that the bases are exactly identical. And once the bases are identical, you can actually go ahead and then you can drop these bases. And then what you're going to equate is just going to be the indices. Okay, so now I have only the 2x minus 1 is equal to negative 3. So from here on, it's straightforward. You are supposed to solve this equation in order for you to find the value of x. Dividing negative 2 by 2 will give you negative 1. Right, the third equation is what we refer to as hidden quadratics. Okay, so there is a clever way or many methods that you can solve this. But I would like to take this x raised to the power of 2/3 and I'll take the square outside. All right, so what you need to remember when you are dealing with indices is that when you have something like this, all right, 2 over 3, this here can be split. This here can be written as 1 over 3 times 2 raised to the power of, or times 2 over 1. So this 2 over 1 essentially is what I'm using, all right, to then do it on this way, because if I was supposed to multiply these two, I will still get this particular index here. All right, so the way is for me to cleverly refer or to get a square power in there. All right, and then I will take out that variable and I will let it be replaced by any letter that I want. In this case, I say everywhere where now where I have an x raised to the power of a third, I'm going to substitute that by k. So essentially then, this is going to be a k square here. So that's why I have 4k squared plus 5k minus 6. Remember, the k is nothing but x raised to the power of a third. So what you have here is now a normal quadratic equation. So you're looking for two numbers multiplied together to give you negative 24. Remember, the way we get negative 24 is by multiplying the value of a and c, which is obviously the 4 here and the negative 6. Right? So once we multiply them, when those numbers happens to be 8 and negative 3, 8 times negative 3 will give you negative 24. And 8 plus negative 3 will give you positive 5, which is the value of b here. Okay, so this is the method of factorization that I'm applying here. All right, you don't need to use the formula and all of those things. So what we have here, these ones in red, are essentially splitting the term in the middle. So now I can factorize by grouping. That's why I can take the terms in pairs. So here you have got 4k is common, and inside the bracket is k plus 2. And here you have negative 3 common, and inside the bracket will be k plus 2. And one way for you to make sure that you have factorized correctly is by trying to multiply out and see whether you get whatever you had right here on top. And you realize it's exactly what I got. So you take then the common factor of k plus 3, k plus 2, and then you put that common factor in its own bracket. And everything that is outside the bracket, you put on in a bracket in its own. So essentially what you have here now is you have two numbers or two factors that you multiply to give you 0. That implies that one is equal to 0 or the other one. So from here, if I solve for k, in this particular case, k will equal to -2. And in this particular case, k will equal to 3/4. But remember, I am not solving for k, I'm solving for x. So I'm going to bring that x back. Okay, so that x where I decided let x raised to the power of 30 equals to k. So I'm going to let it come back here. All right, so when I do that, I am going to end up with x raised to the power of 30 equals to -2. Now remember, I put it in brackets. And the way you do is to isolate this 1 over 3 here, that power, by simply multiplying it by the inverse. And what you do on one side, you also do on the other side. And then you realize one solution is x equals to -8. Another one for x equals to 3/4. Again, you multiply that index by 3 over 1, its inverse, and then you raise the same thing on the other side, and that should give you x equals to 27 over 64. Right, so this brings me to my fourth question, which is rather a very long equation here. Now I'm doing this one for Nga. Nga is my family member. He requested me, so I am going to assist you. So I hope you follow the steps and you compare with what you have done. So what you have here is typical an equation that has got some terms on the left, two terms to be exact, fractions that are subtracted, and two terms on the right, and fractions and numbers that are being added. So the first thing you should do, always try to introduce brackets here, all right? And what I have done here is I have changed a few things here. So first of all, you would see that the 2x squared minus x minus 3 is a quadratic expression. So we are going to also factorize that one there. And I also factorize the 12x minus 12. Essentially, it's not necessary, but you never know whether you can find common factors. But since you're subtracting, okay, we are not really needing to do that for that particular term. However, there is something on this particular term here. If you can see, you have 2x minus 3 here. All right. So when I do the factorization of the 2x squared minus x minus 3, I will end up with 2x minus 3 and x plus 1. Refer to the previous question to see. Look for two numbers, multiply, that give you -6. And if you add them, they give you -1. And you do that on the side, and you eventually end up with this. Right, so I have 2x minus 3 in this term, and there's a 2x minus 3 in this particular term. So what I've done here is I've changed this minus, this plus to a minus in order for me to swap this around. Okay, so essentially it is still the same thing. So if I had 4 minus 5, all right, and I was to rewrite it as 5 minus 4, I would be changing the sign and I put a minus here. And what you would see here is that our answer will exactly be the same. This negative times 5 will still give me the -5 that I have up there. And this negative times -4 will still give me this +4 that I have here. So that is exactly what I did with this particular fraction, all right, in order for me to change the sign here and to swap these terms around. So essentially it's the same thing. All right, so the next thing that I have done now, okay, is I have then move this particular term so that it can go meet its friend, so to speak, okay, all the terms that contain these expressions of x. Now, what you realize is, that the LCM is 2x minus 3 and x plus 1. So this particular one does not have x plus 1. And this particular one does not have x plus 1 either. Okay, so the LCM is then the whole 2x minus 3 and x plus 1. So I can put everything actually on top of that denominator. Okay, so everything can be therefore placed on that denominator. Right, so what it leaves me with is a numerator that I can also, now I have to simplify that numerator, and I will also cross multiply that 2x minus 3 and the x plus 1 with that 2 there. So I have done it then on this particular slide here. So you would see that I have first multiplied throughout by 2. So now, and then I've also removed the brackets of the terms on top. So it looks kind of messy, a very long story here. So when you do it, eventually you should end up with 4x squared minus 8x plus 14. All right, and then on the right, if I clear that up, I should end up with 4x squared minus 2x minus 6. All right, so now if I have here, I have to let it equal to 0. So what I did is I move all the terms then, and the 2x squared becomes a minus. The 8x here, the negative 8x becomes a positive 8x, and the positive 14 becomes a negative 14. Now when you clean this up, you eventually end up with 2x squared plus 6x minus 20. And remember, if it seems like I'm going too fast, you always have the luxury of pausing the video and writing down and see how I arrived at this particular expression. So I can see there's something common. There's a 2, a 6, and a negative 20. All right. So I can divide throughout then by 2. 2 goes into x squared, leaving you with x squared, and 2 goes into 6x, leaving you with 3x, and 2 goes into negative 20, leaving you with negative 10. 2 goes into 0, 0 times. So what I'm left with here is a quadratic expression that factorize, and you realize there's two numbers that are multiplied by itself to give you negative 10, and when you add those numbers, it's going to be positive 3. Those numbers happen to be 5 and negative 2. Therefore, giving me my two answers, one answer is x is equal to negative 5, and the other answer is x equals to 2. Right, the last equation that I have here is log equation, log 5x minus 11. Now I'm always saying is equal to 2. I'm always saying to the students, what you need to do is, you must take that stuff there, okay, inside the bracket when you have something like that, and you should let that stuff, remember, that stuff should always be, this stuff here should always be greater than 0, okay, because log 0, okay, it does not exist. All right, we don't have something like that. So log 0 does not exist. It does not exist. So we cannot let that particular x to be some number that when we plug it in here for x next to the 5 and minus 11, and then we're going to get a 0 there, or a negative answer. So the log of a negative value also does not exist. So this number here, your log n, this n here, that n should not be, it should be, n should be greater than 0. That n should be greater than 0. That number here should be greater than 0. Okay, so that is the first thing I do. So essentially what I'm doing then is I'm going to make an inequality to see what the value of x should not be, such that when I plug it into that, and I should not get equals to 0. So when you do that, if you take your calculator and you plug 2.2 here, you realize you get a 0 here. So when we get an answer, essentially when we work and we solve this thing and we get an answer of 2.2, we're not going to consider that answer. Okay, so then it will not make sense. All right, so the first thing then, I'm going to rewrite this from log form to index form, because remember, essentially what we have here is a common logarithm, all right, which is the base of 10, and then you kick that particular 2 upwards in order for you to change. All right, so when you have log base 10 of some number, all right, equals to x, right, then if you rewrite it from log form to index form, it becomes 10 raised to the power of x is equal to 5. So this is just an example of how to rewrite something from log form back to index form. Okay, so that is exactly what I'm going to attempt to do. So I'm seeing that there is a base of 10 because we are dealing with the common logarithm. All right, and since we are dealing with a common logarithm, and I'm going to write that base 10 here, and now I'm going to bring in my little arrow. I always say let that kick that one upwards there, and when it does that, it becomes 10 squared. Now 10 squared is equal to 100, equals to 5x minus 11, equal to that stuff there. So from here you have a linear equation which you can solve. All right, so you have 111 is equal to 5x. Now, the only thing left to do is to divide by 5, and when you divide by 5, you realize you get an answer of 22.2. Now, this particular answer will work out because the only answer that we can't consider is 2.2. All right, so when we have something like 2.2, we should not consider it. Our answer should be bigger than 2.2, and of course 22.2 is much bigger, all right, than 2.2. So that is our particular answer. Right, so that brings me to the end of this presentation. It was a quick one. I want you to go back and check them again.